Hi everyone, in this video I'm gonna talk about resistors in parallel. In my previous videos, if you watch, in my previous videos we talk about resistors in series. Now we connect resistor in parallels. So let's inspect that resistors. If they are parallel, what's happening? We already know what is parallel connection. So, what was parallel connection? Make me remind you. If I am coming, here is A, so I am coming A, and also I am coming A because I am same wire. I am passing through resistor. Let pass through that resistor. So here is different node B. That B is going to here, B, and that B is going to here. That resistor 1 is parallel to resistor 2 because their ending and their starting point A and their ending point is B. They are same. If I add here also third resistor, also they are parallel to each other because ending and starting point is same. So let's inspect what's happening here. If so voltage AB it's equal to, if here is voltage drop 1, voltage drop second, and voltage drop third, is voltage 1 and voltage second and voltage drop third. They are voltage drop between legs of resistors same. So we didn't divide voltage. If we have, for example, 12 volt in here, our voltage supply, our voltage drop is, all of them are equal, 12 volts. Yes. So what we are dividing here? Parallel. For what? Parallel connection. Parallel connection dividing current. Now, if you think you are current, you came to first junction. Yes. So you must, if it's 100% here, so you must divide. Maybe here 50%, maybe here 30%, 40%, and remaining how much? 30% again. So you are dividing your current. I2 and I3 is passing. But I know I is equal to I1 plus I2 plus I3. I1 passing through here, I2 passing through here, I3 passing through here. All of them here is collecting like pipe, like water pipe. All of them collecting and all of them passing through just one pipe. So I is equal to their sum. So okay. So how can I calculate? I? First method, I can, if I know voltage drop, I can calculate I1, yes, I2 and I3 and so on. So I will make sum and I can calculate my I. So there is equivalent resistor. And how can I calculate that one? First, this equation I will use, yes, and from Ohm's law I can type I equal to, it's Ohm law, yes. So if I type ohm law in here and let me type it like total, I total is equal to, it's I total, so is equal to I1, I2 and I3. So I can type I1 is voltage 1 divided by resistor 1 and voltage 2 divided by resistor 2 plus voltage 3 divided by resistor 3, and of course it can go to IN, to unlimited it can go. Of course in the real world there is no unlimited. Let me type here Vn divided by Rn. I know that one. So if and I know W1, all of voltage drops are same. Yes, V1 equal to V2 and equal to V3 and VAB. So VAB is also equal to voltage, general or supply voltage. So from here, let me come to here. So let me type I total again to here. I total is equal to what can I type? It's equal to, I can type like that, is RA is equivalent resistance. I will put one resistance equal to all of three of them, or n of them is equal to. So if I also they are equal to V and V. So in parentheses V is equal to, so let me pass here, 1 divided R2 and 1 divided R3 and so on. Look, how come to here? First, I know voltage drops are equal, same. Okay. I know, also I type, and I know I total equal to I1, I2, I3. So from Ohm law, I type I total is equal to voltage 1 divided by voltage 1 divided by resistor 1. It's that one. That one is that one. And that one is this one. And that last one and last one. They are same. So, and also I know V1 is equal to V2, V3, they are equal to volt, general volt. So I type, instead of V1, V. Instead of V2, V second, V. Instead of V3, V. So I am typing again, I total is equal to, using that one, voltage divided by resistance, equivalent I didn't show in here, now I will show, is equal to, in parentheses V, 1 divided by R1 plus and same to all of them. So if here basic mathematics rules, so our formula like that for equivalent resistance, I am below here, is equal to what? 1 plus 3 and so on. So on. Of course you can, it's not a good show like that, 1. So 1 divided by equivalent. So you can flip that equation. So equation will be, now I am relating here, my equation will be, I am deleting here. Of course you can pause your video if you didn't understand. So I am typing that one again to here. It's equal to, so equivalent resistance is equal to 1 divided, same that, but just I am showing more aesthetic. Like that. So the equivalent circuit, something like that, yes, are equivalent, and our equivalent is, so if here's just three of them you will put in this formula. So now let's make our one example I will give you. In this video I don't want to give the practice by voltage supply like that, because we already know in series. After that there will be more complicated, of course, videos. In every video I will do that physical demonstration also. Now example. Now look at our example. There is given here 12 volt, resistor 1 750 ohms, second one 1 kilo ohms, third one 2 kilo ohms. You already know kilo is like kilobyte or kilogram, 1000 ohm and 2000 ohm. So what is our I total current passing from that main wire here, and what is our if I put one resistor, what is our equivalent resistor? Or we will draw our equivalent circuit. So what if I want to calculate that I know from here is from passing I1, I2 and I3. Yes? What is our I? I is equal to I1 plus I2 plus I3, because I3 passing here, coming here, I3, from that wire coming I second. After this node to here, they are passing in here, that I is passing from here, I second plus I3. I3 came from here. They after this joint, it connect to I second. They are together going now. After this joint, they are going together. All of them, 3 of them. So I is equal to, also here is I, is equal to that one. What else I know? Their voltage drop between legs are same. So also it's equal to our voltage supply, because that wire connect just here. There is no any obstacle, yes? So I know voltage, and so I can calculate I1. So let me calculations near me. So I1 is equal to voltage 12 divided by resistance. I1 is equal to 0.016 amps, so 16 milliamps, and so on. We will calculate I2 is 12 volt, again same voltage drop, but divided by 1000, so it's equal to 12 milliamp. Look here, resistor is bigger than that one, R2. R2 is bigger than R3. So I2 is smaller than I1. Because what is resistor in components? Resistor, that the electronic component that I showed you in my previous videos, it's on the name on it, it resists the current flow. So I3, I'm calculating I3. Okay, is equal to 12 divided by 2000. Yes, now 2000. 2k ohms, 2000 ohms. 0.006 or is equal to 6 milliamps. Look, I already know. I1, I know, checked. I2, I know, checked. I3, I know, checked. If it's I4, I5, 6, 7 to N, I know. All of them I know. So our I is 16 plus, all of them milliamp, just I will tap at the end milliamp. So our I is 34, all of them milliamp, so it's also milliamp. So I found 33 milliamp. So let's calculate equivalent resistor in different way. I can calculate, how can I calculate? If I will divide, yes, if I will put 12 volt is equal to 30 milliamps, I can find from here, I can find. But let me find that formula which we already know. So what was our formula? Also, by the way, I don't like formulas, so I am deleting that one. We already calculated. We already calculated, yes. What was our formula? Resistant equivalent is R1, I'm sorry, 1, wait, 1000 and 1 divided by 2000. If you do this one, and don't forget you are doing this one, after that you are dividing that result 1 divided by this result which you are doing here, like simple mathematics. 1 divided, don't forget, divided by this numbers, by this operation. From here, our equivalent circuit, our equivalent resistance, it's yes, 352.94 ohms. How come it's, we know in series, okay, it was so logical that we are adding in resistors when it's series, but when it's parallel, how come that resistors smaller than all of them? Smaller, it's the smallest value. How come? So easy. It's so easy. Because I am putting that I is sum all of them, and I must put some resistor value because that I is bigger than each, it's bigger than that one, it's bigger than that one, and it's bigger than this one. Yes, bigger than I1, bigger than I2, bigger than I3. So I must put resistance smaller if I compare all of them. How come? Now I am typing here what I talked. I'm so sorry I couldn't talk. I will not relate this video, this part, because how? Look, it was I1, I2 and I3. When resistor is biggest one here, R3 is the biggest one, so there is less ampere passing, less current passing, yes, 6, 12 and 16. But if I will put that equivalent, now I am drawing equivalent circuit here. If I am putting equivalent, what we calculate, 352.94 ohms, yes? Look, why? Why it's smaller from all of them? Yes, because why? I must put one resistor and it's related to that I. So I, in that one, I is bigger, all of them from bigger from I1, bigger from I2, and bigger from I3. So resistance, like reverse, vice versa, our resistor must be smaller than R1, smaller than R2, and smaller than R3. That's why our equivalent resistance is the smallest. So let me check if we calculate correctly in that one. So here is 12 volt, yes. If we find, here is that resistance, if we find same ampere, so we already did correct. What is ohm? Formula saying us voltage 12 ohm law. I am typing 12 is equal to I multiplied by resistance. Yes, what is our resistance? 352.94. If you do calculation, our I is 0.034 or it's equal to 34 milliamp. So our first calculation also correct. It's that result, verify that one. Or vice versa, that result, verify that one. So we already know how to calculate resistor in parallel. In that video I'm not gonna do demonstration. Next video, previous videos we designed how can I say, voltage divider, but we in that load resistance we say that our load, it can be motor IC, I gave that IC, it has so big resistance that is negligible. But now we will not, I will give you, in next videos I will give you an example, and we will calculate also not negligible resistance, not negligible load resistance. So keep watching. Bye.